next topic we're going to discuss is about the average rate of change. So if A and B are two numbers in the domain and they aren't equal, and then we would calculate the average rate of change of f from A to B to be defined as the change in y over the change in x, which would be f of b minus f of a over b minus a, right? We've also heard this referred to as the slope, right, when we have a linear equation. But when we do not, it's the average rate of change. So here I have a quadratic. I have f of x equals 3x squared. So I'm going to calculate as we go the average rate of change from 1 to 3, 1 to 5, and 1 to 7. So 1 is our a and 3 is our b. So if I take f of b minus f of a over b minus a, that gives me 3 minus 1 in the denominator. And then I have 3 times 3 squared minus 3 times 1 squared, which is 27 minus 3 divided by 2. That gives me 24 divided by 2, which is 12. So the average rate of change from 1 to 3 over this quadratic function would be 12. Let's take a look at 1 to 5, and let's change colors. So if I have f of b minus f of a over b minus a, that's 3 times 5 squared minus 3 times 1 squared over 5 minus 1. That gives me 75 minus 3 over 4, so 72 over 4, which is 18. You can see as we go further and further apart that the rate of change is increasing. And that kind of makes sense if you think about the shape of a parabola. The slope between these two lines has less slope than the slope between these two or these two. So let's take a look one more time at the rate of change from 1 to 7 of this parabola. So if I have f of 7 minus f of 1 over 7 minus 1, that's going to be 3 times 7 squared minus 3 times 1 squared over 7 minus 1, which is 6. I've got 144 in my numerator. 144 divided by 6 is 24. So as you can see, the rate of change is increasing. Let's take a look at at a good visualization. Let's look at this graphically. So here I have my function. This is the function f of x equals 3x squared. I know I cut it off a little soon, and I'm sorry, but as you can see, here's our slope from 1 to 3. Oh, it's just barely off, right? Our slope is 12, right, of this, the rate of change of this line, which is the slope, and it gets steeper and steeper as my parabola goes further and further up into infinity. I made this graph in Desmos. That's a good place to go and look and see what graphs are doing. We can also describe the average rate of change as the slope of a secant line. So this would be the average rate of change of a function from a to b, and it would contain the points af of a and bf of b. And that makes sense, right? Because f of a is really just our y value. So you can use the point slope form to find the secant line with this information. Once you've found your slope, you can pick either of these 2 points and substitute them in using point slope form, which in case you forgot is y minus y1 equals m times x minus x1. So why don't we go ahead and work through an example. So here I have the function f of x equals 3x squared minus 2x plus 3. And I want to find the average rate of change from -2 to 1. So -2 is going to be my a and 2 is going to be my b. So I'm going to find my average rate of change, which is the slope of our secant line. And that's going to be f of b minus f of a over b minus a. So I have 1 minus a -2 in my denominator. Then I have 3 times -2. Nope, 3 times 1 squared minus 2 times 1 plus 3 minus 3 times -2 squared minus 2 times -2 plus 3. That's going to give me 3 times 1 squared is 3 minus 2 is 1 plus 3 is 4. 3 times -2 squared, that's 3 times 4, which is 12. 12 plus 4 is 16 plus 3 is 19 all over 3. So I get a slope of -15/3, which is -5. So I have a negative slope. Next, I'm going to find the slope equation of a secant line containing these 2 points. Well, I already know my slope, so that's nice. I don't have to use these 2 points to calculate point slope form. We found that f of 1 was 4, and f of negative 2 was 19. So I have the point negative 2, 19, and 1 comma 4. Now, in order to use point slope form, it doesn't matter which point you use. I'm going to pick the easier one. So I've got y minus, and by easier I mean it's smaller numbers, it's less difficult mental math to do. Y minus y1 equals m secant times x minus x1. Then I go ahead and substitute in. Y minus y1, which is 4, equals negative 5 times x minus 1. That's going to give me y minus 4 equals negative 5x plus 5. Add 4 to both sides. I get y equals negative 5x plus 9. And this is the equation for the secant line. Let's go ahead and take a look and see what this is graphically. So here I have in red the graph of my parabola. And then in blue here, I did the graph of the secant line we just found. It does contain the 2 points when x is negative 2, y is 19, and when x is 1, y is 4. It does have a negative slope we can see from the graph, and it does intersect at 9 because 9 is our y-intercept. Okay, so this is what the graph of our secant line would look like